Hi, my name is Giorgio Curatolo. I'm a solution architect in the Americas domain, and I work on the mobility management solutions. Today I'll be demonstrating our virtualized HSS running on a standard DL385. I'll give a little bit of history on our HSS platform. Basically, the HSS comes from our heritage in our HLR solution that's been deployed worldwide, servicing about 400 million subscribers. Today, the demonstration is based on that application that has been ported out to work in the Linux and a virtualized environment. The solution consists of a EPS and IMS HSS function running in a virtualized environment. The application itself has the capabilities similar to that we just demonstrate in our IHSS solution, using synchronization and mated pair configuration design. The database and the call function control is running in our virtualized environment, and as I perform the demonstration, I'll show each of the aspects of the HSS capabilities. For today's demo, I'll be focusing primarily on our IMS component, using the partner CSCF and our HSS running in a virtualized VMware hypervisor. The application is running on a standard DL385, which is running in our server here at the booth. I have a VMware client to act as the hypervisor. I have a CSCF and an HSS deployed. Some of the monitoring tools, I'll be running a trace to demonstrate how messaging is flowing between the two applications and between the client devices. I have a few clients that I'll use to authenticate against the HSS. The purpose of the HSS is to authenticate the devices. Today, we'll be focusing on SIP digest as the authentication method, and I'll start with a quick selection of our SIP client. The SIP client is provisioned with the mobile number that has already been added into our database. A few of the key components is that we're leveraging all of the technology we currently have in our HSS nonstop solution. They've been ported out and functioning in this environment. The subscriber profile that we'll be talking about is an IMS profile. I'll be using this mobile number or user ID to demonstrate in today's call. I'll begin by provisioning a number that does not exist in the database. It attempted to contact the HSS for authentication credentials, but it failed. The HSS returned an unauthorized message based on the authentication request because the number does not exist. Now I'll use a real number that is provisioned in the database to prove that the HSS is performing the authentication. The client has connected and established the registration. The multimedia request has been accepted. Now the device is ready to receive calls. I also have a tablet that's registered and authenticated on the HSS. This device is already authenticated. We'll attempt to make a call between the two clients. We've connected. We have a call in progress. I can select video, and the video is being displayed on the client side. That's just a basic overview of how the HSS is functioning. Typically, a single instance of our HSS can support a certain amount of subscribers. In the event that we need to scale, we can deploy additional instances. In this demonstration, I'll basically show the effort it takes to deploy a completely new HSS instance. Using the hypervisor tools, I'll select a template that's pre-built with the HSS configuration. I'll give it a unique HSS name, select a few parameters, and then configure it to power on once the instantiation completes. This process takes about 2 minutes. In our production version, we'll typically have some configuration steps to identify the HSS unique identity. There'll be IP configuration. In this demonstration, I'm merely just showing how someone would deploy a single instance of an HSS. We can also scale the other network elements. One of the main advantages of using the hypervisor and virtualization in general is that we can share the physical hardware with multiple applications. And in this environment, I have VHSS, CSCF, and I can also demonstrate a EPS load generator to generate traffic to the HSS. In the background here we see I can queue up an application load generator to generate traffic on the HSS. Now we can see all the messaging hit the HSS. I'm generating a few 100,000 messages to the HSS demonstrating its ability to process these types of transactions. This is using the S6A interface. We'll start to see the HSS utilization and the CPU consumption increase as we're generating a load on the system. During that time, we've had successfully deployed an additional instance of our HSS. Theoretically, that would have given us an additional X number of millions of subscribers available in the same environment, simply by deploying another instance of our HSS. Our typical configuration is a mated pair, so that there is no single point of failure inside of a single physical piece of hardware or in a hypervisor. So we utilize our technology, our heritage in synchronization, and we're moving that into our virtual HSS. Generally, that covers the overall capabilities and simple implementation. The objective is to drive towards POCs and evaluations of our solution inside the carrier space so that they can target some of their use cases. Some of the use cases we've identified are M2M and MVNO type implementations. So these are the type of use cases that we see a huge advantage for leveraging virtualization. Some of the more difficult questions that were asked here at the show were, why virtualization? How can it scale? How available? How can we ensure stability in the environment compared to the traditional purpose-built solutions? Some of our responses targeted our understanding of high availability, geo-redundancy, and utilizing some of the software components like synchronization. These are some of our strengths in being able to ensure platform and application synchronization and high availability.